do one simple thing. Listen carefully to every single word. I guarantee 80 to 90% of this topic will be ready in your mind right now. Physics is actually very easy.
Uncertainties. It's very easy topic. I'll try to explain uncertainty with the help of an example. In example, I'll use the scale and a marker to explain uncertainty. It's very easy. I'll try to explain the uncertainty with an example. In example, I'll use the scale and marker to explain uncertainty. Once you understand this example, this whole theory will become super easy for you. I'm repeating. Once you understand this example, this whole theory will become super easy for you. So be carefully. Let's begin by looking at this scale closely. On this scale, the distance from 0 to 1 is 1 centimeter. cm. cm means 1 centimeter. cm stand for centimeter. The distance from 1 to 2 is again 1 centimeter. 1 centimeter, 2 centimeters, 3 centimeters, 4 centimeters, 5, 6, 7, 8 up to 19, 20 centimeter. This scale has 20 centimeters in total. Now, from 1 to 2 is 1 centimeter. 1 centimeter is further divided into 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This 1 centimeter from this line to this line is 1 centimeter. This 1 centimeter is further divided into 10 equal parts. This 1 centimeter is divided into 10 equal parts. 1 centimeter is divided into 10 equal parts. Then after 1 divided by 10 is equal to 0.1. You can verify by using calculator. 1 divided by 10 is equal to 0.1 centimeter. It means the smallest division is 0.1 centimeter. It is also the least count. Least count of this scale is 0.1 centimeter. Least count is the smallest or the minimum value that the instrument can measure. Look here. One centimeter is divided into 10 equal parts. 1 divided by 10 is equal to 0.1. 0.1 is 0.1 centimeter. 0.1 centimeter is from here to here. And 1 centimeter is from here to here. This is 1 centimeter, and from here to here this is 0.1 centimeter. This is the minimum value of this instrument that can be measured accurately. It's a least count. This is the minimum value. This minimum value is 0.1. So this minimum value is known as least count. Least count is the minimum value of the instrument that can be measured accurately. So the least count of this scale is 0.1 centimeter. This is 0.1 centimeter and this is 1 centimeter. Now 0.1 centimeter, 0.23 and 0.9 and then 1.09, then 2, then 2.1, 2.2, 2.3. Now we will measure the length of this marker by using this scale. the length of this marker by using this scale, and the length is sorry the length is almost 14, 14.1, 14.2, and 14.3, almost 14.3. The length of this marker is 14.3. The length of this marker is 14.3 centimeter. Now, what is the uncertainty? Look here. The length might be slightly more than 14.3 or less than 14.3. Slightly more than is maybe 14.4, or slightly less than maybe 14.2. It's a 14.3. The length might be 14.4 or 14.3. Now, this is the uncertainty. Look here, the length is slightly more or slightly less. How much more or less? Half of the least count. This is the least count, then half of least count. Half of 8. Half of 8 is 4. 8 divided by 2, 4. Similarly, half of 0.1 means 0.1 divided by 2, which is 0.05 centimeter. You can verify 0.1 divided by 2 by using calculator. You will get 0.05 centimeter. 0.05 is the half of the least count. Least count is the minimum value, and this is the half of the least count. So the length might be slightly more. How much more? 0.05 more or 0.05 less from both ends. From one end, while measuring the length, the length might be 0.05 more from 14.3 at this end, or less at same at this end, 0.05 more or less. In simple way, the length might be more or less, plus or minus 0.5 at this end and same at this end, plus 0.5 centimeter. Then 14.3 centimeter plus minus 0.05, sorry, 0.05, 0.05. 0.05 plus 0.05 is equal to 0.1 centimeter. You can verify 0.05 plus 0.05 centimeter. 0.05 plus 0.05, you will get 0.01. This is the measured value. This is the margin of error. Margin of error is how much? If we add 0.1 plus or minus, if we plus 0.01, this will be 14 point, or we minus, first minus or subtract it, you will get 14.3 minus 0.1, you will get 14.2 centimeter. Now add 0.01, then you will get 14.4 centimeter. If you minus, you will get 2. If you plus, you will get 4. So this is the range. This is known as uncertainty, or this is the uncertainty. This is the U uncertainty, or this is the range of uncertainty. Hope you got the point. The length what does it mean? It means the length of this marker is not exact 14.3. It lies between 14.2 and 14.4. This is known as uncertainty. The range of possible values. Look here. Certainty is the range of possible values within the true values lie. True value lies. It's a range of possible values. The length of this marker is in between. This is the range of possible values. So uncertainty is the range of possible values within which the true value lies. Or another definition, the margin of possible error. If we measure through this scale, there is a margin of error. How much error? Error can be 0.1 centimeter plus minus 0.1. This is uncertainty. Margin of error or range of possible values is known as uncertainty. Hope you got the point. Margin of error. Another definition, the margin of possible error around a measured value. Around a measured value, 14.3 is our measured value. It's around the measured value. 14.3 around 14.2 and 14.4 around a measured value. The margin of error is known as uncertainty. These both are the definition of uncertainty. Hope you got the point. Now, for example, in this example, after plus minus, this is uncertainty. This is plus minus 0.1. This is the uncertainty and this is the measured value. So in this example means the actual values lies between 37.5 minus 0.1, you will get 37.4, and plus 0.1 you will get 37.6. 37.6. So the actual values lies between 37.4 and 37.6 centimeter. Now, important point. All measurements have uncertainty due to. All the measurements have uncertainty because of limitations of measuring instrument. This instrument has some limitations. Screw gauge has another limitations. Vernier caliper has their own limitations. So every instrument, clock, stopwatch, also has some limitations. So every measuring instrument has some limitations. So the uncertainty occurs because of the limitations of measuring instrument and the skill of experimenter. I'm doing experiment here. I'm experimenter. The skill of the experimenter and the limitation of the instruments. That because of these both, uncertainty occur in every measurement. Now, types of uncertainty. There are three main types: absolute uncertainty, fractional uncertainty, and percentage uncertainty. Now, absolute uncertainty, what does it mean? It's usually equal to the least count or half of the least count. Look here. The least count of this scale is 0.1 centimeter. The uncertainty is 0.1 centimeter, or at both ends, half of. Half of 8 is 4. Half means divided by 2. 0.1 is least count. Least count 0.1 is least count divided by 2 means half of least count. So absolute uncertainty is least count or half of the least count. Absolute uncertainty is equal to the least count or half of it. It means least count with the same units as the measurement. The measurement is in centimeter, so the uncertainty is also in same centimeter, not in millimeter or meter. Same units as the measurement. Now, look here. Absolute uncertainty. Absolute uncertainty is denoted by del x. This is the absolute uncertainty, plus minus 0.1 centimeter. Plus minus 0.1 centimeter, this is the absolute uncertainty. Absolute uncertainty is represented by del x. Is represented by del x, and the measured value is represented by x. This 0.1 is also the least count. Also the least count of this scale. So it's also a least count. It also a precision or precision of this measurement. I already explained in previous lecture. If you didn't get this point or didn't take that previous lecture, must go through it. I will put the link in the description. Now, this is the absolute uncertainty. Now, what is the fractional uncertainty? Fractional uncertainty is the ratio. Look here. As we know that 2 divided by 3, we can say 2 ratio 3. They both are same. 2 divided by 3 or 2 ratio 3. Same here. Fractional uncertainty is the ratio of absolute uncertainty to the measured value. This is the absolute uncertainty, and this is the measured value. So the ratio of 0.1 absolute uncertainty to the measured value. Measured value is 37.5. This is known as fractional uncertainty. Fractional uncertainty is the 0.1 divided by 37.5. 0.1 divided by 37.5. This is the ratio of absolute uncertainty to the measured value. The ratio of this to this. Ratio of uncertainty to the measured value is known as fractional uncertainty. Del x divided by x is fractional uncertainty. The ratio of del x to x ratio or division. This is fractional uncertainty. Fractional uncertainty. So after division, you will get 0.03. This has no units because this is in centimeter. This is also in centimeter. Centimeter divided by centimeter, they both will cancel out. So fractional uncertainty has no units. Now this has units, but the fractional uncertainty has no units because the ratio of two similar quantities. Now percentage uncertainty. Same del x over x, only the difference multiply by 100 with percentage sign. This is known as percentage uncertainty. Del x over x is fractional uncertainty. So percentage uncertainty is the fractional uncertainty. This is the fractional uncertainty. Expressed as percentage. This is expressed as percentage. This is the percentage uncertainty. P percentage U uncertainty. Percentage uncertainty is equal to this. Same 0.1 divided by this multiplied by 100%. You will get this 0.3%. Now, note, important note. Smaller fractional uncertainty or error, higher accuracy. I already explained with the help of diagram in my previous lecture. Must go through this lecture, and smaller least count is equal to higher precision. They both are already explained. I will put the link in the description. Now come here. In grade 9, we already studied types of errors: human error, systematic error, or random error, and the causes of error. The cause of human error is negligence or inexperience of a person. Why human error occurs? Because of inexperience of a person or carelessness or negligence. Number two, systematic error. Systematic error occurs because of a faulty apparatus or wrong method or technique. The systematic error occurs. Random error. Random error occurs because of any random change, for example, change in temperature, change in airspeed, etc. We already studied in previous class.